Hey, it's me, Steve. It is May 24th, 2017. Time's about 17:41. I was going to do this in my Jeep, but my phone ran out of storage space. Surprise. So I'm in my house doing this one, but I just did accuracy and precision. Now I want to talk about collecting statistics and data points. But the example I'm going to give is for linear functions or functions in general. I'm not going to address multiple curves or anything like that. This is for illustration purposes only. Okay. Now, there's one, when people, no, statistics don't lie, people do. When collecting statistics, and a lot of people who are trying to present a false topic to you or false statement to you will often use statistics to back themselves up. They'll either misrepresent the statistics or they will pull one or two data points to illustrate their point. And I'm going to get into why that's a total crock of shit and doesn't mean anything. But I'm going to show you some examples. But one data point, two data points, and three data points are never, ever, ever a trend. Okay? If somebody is presenting, and when I say data points, it doesn't even have to be actual data points on a graph. I mean, if somebody's collected a bunch of data and they just pick what we call an outlier or illustrate a data gap and use that as evidence of something else, they're full of shit. But I just want to show you how you can manipulate statistics. By the way, three data points. If you're like in geotechnical engineering, there's this test that we used to run called it was a soil compaction test. Basically, you put the soil in a cylinder and you pound on it with a big hammer, different moisture contents, and you put it in the oven, dry it out, weigh it. And what you'll do is you'll get three data points, and they should form a line. Now, I'm going to sit here and tell you how three data points is not a trend, but in that case it is. Why? Because that experiment has literally been run hundreds of thousands, if not millions of times. And it's always formed that straight linear slope. The slope may be a little up or down depending on the type of soil, but it has always worked. But you still may want to run more than three data points. Three data points, what if you massively screwed up one of the points? That could throw your results off. So in that kind of test, you kind of want to at least do five. But that was just a little side note from experience. But one data point is not a trend. I tried to highlight the data points here. It's a little dark in my house. I should probably turn some lights on. You collect one data point and then say you decide that this is your trend. How's that possible? That's a fail times infinity. How do you know the actual curve isn't like this dashed line? How do you know it's not actually like this? The dashed line again. Or how do you know it's not any of these? This is the line you assumed. I've got a dash on, how do you know it's not this one? How do you know it doesn't go like this? How do you know it's not like this? How do you know it's not like this? You cannot extrapolate a trend from one data point. Okay? You can use that data point as a starting point for an idea, but it doesn't mean anything in and of itself. And people who are trying to sell you something on one data point are either lying to you directly, or they're so full of they've been so baffled and beaten with shit themselves that they can't tell the difference. All right? Two data points is also not a trend. You collect 2 points and you draw your line here, and I think the points are right there. Okay, that's not a trend. Yeah, they'll form a line, but you run into the exact same problem. How do you know this dashed line isn't your actual curve if you were to collect more data points? Or this function, same thing, dashed line. All right? 3 data points is also not a trend, and unless you're running something that's been firmly established, like I explained before. But if you're doing something new, you pick 3 data points, 1, 2, 3, and you decide that's your line. Okay? Oh, that's cute and all. But, I'm not going to get into margins of error, standard deviation, all that stuff. I'm not going to give you equations, but I'll explain those. But how do you know your line isn't like this dash line? All right? How do you know it's not like that function? Or how do you know you even have, like in my last video, accurate and precise data? I mean, how do you know this isn't your line? You can see the points, and how do you know that one's not an outlier? You don't, okay? It's not a trend. So here's an example of just a graph. Say you collect 37 data points, 3 dozen in one, and you get something that looks like this. Go ahead and count them if you want. Notice the one up here. I'm going to get into that in a minute. This shows a definite trend, okay? You can extrapolate a line from that trend. And note, see, you can do this. This is fine. By the way, up here I've defined margin of error. Hope you can read that. And down here I have described standard deviation. Margin of error, this graph doesn't show margin of error, it's a graph, but you can tell by how the data points fit really close to the line that you have a low standard deviation. And that's good. That means you're precise. Doesn't mean you're accurate, but it means you're precise. But you notice here I also have a data gap. Okay, sometimes when you collect data, you get gaps. You have to identify those gaps. You do have one point that fits the line, but you can see you do have a general gap right here. But the one point you do have does kind of fit, so you can still continue that line, but you have to explain that data gap. Why did that occur? Why do you think it's not relevant with all these other points? You need to explain that. And you have this one out here. This one's called an outlier. Okay? There's a lot of people who will ignore all this and focus on that. Well, what causes outliers? Well, number one, an outlier can be caused by mistaken measurement. It happens. Your experiment may not be set up the same way. You may tweak something a little bit that you didn't mean to. This is why we have controls when we run experiments, okay, to minimize outliers, okay? An outlier in and of itself does not mean it's a valid data point. It's a 99.999999% chance you screwed up somewhere. It's human error, and that's okay. People make mistakes, but you need to recognize that, okay? Now, if we didn't have any of these data points and it stopped maybe like right here, and we had that, it's possible that this could curve up. We see this outlier and we're like, oh man, So we run more data points, we get the rest of these and realize it is a legitimate outlier. It is not a relevant data point, okay? And it can be discarded. When you have 36 forming nearly a perfect line and one out in the middle of nowhere, it's an outlier, all right? And people who like to mislead, manipulate statistics will often focus on one outlier point, all right? Outliers can also an outlier is not always necessarily incorrect measurement. It almost always is. But an outlier can point you in a different direction. Be like, okay, you run an experiment, you keep getting that outlier. Chances are, well, since you did get a definite trend, your method's fine. Your accuracy and precision is fine, but you've got something telling you something else. So you'd have to reset and try to reproduce that outlier. If the outlier disappears, it's no big deal. You forget about it. If it keeps appearing, you have to explain it. It does become a necessary explanation. But that almost never happens, or it could be a key to something else unrelated. But when you have something like this here, and one outlier, and you present your data, like this, and it's all valid data. You have a good sample size. You've run, all these experiments. You've detailed your methods. You've made accurate predictions, and this line always checks out. And you got this one here. Some idiot is going to come along, take this, and sit there and use it for evidence for bullshit. All right. So that's one of the ways you can lie with statistics. But I just wanted to show you how to properly read like a simple data chart, your x-axis, your y-axis. I didn't label anything here. Like I said, this is for illustration purposes only. But I hope that explains and clears some things up for you. Leave some comments if you want. And I hope you learned something.